So the concept of diagonalization we have to just carry forward. I told you the concept of similarity transformation, in which a matrix A is converted into a matrix A cap. Okay, using a transformation, a matrix A is converted to A cap. And what is the definition? A cap is equal to P inverse A P. So this is the transformation, and if this is done uh, using some suitable values of P inverse and P, so in some cases it will become a diagonal matrix. So we can write D is equal to P inverse and A P, and D is known as a diagonal matrix. D is known as a diagonal matrix having only non-zero elements at the diagonals, having only non-zero elements at the diagonals. And please see this. So if this D is equal to P inverse AP, we can write A is equal to P D P inverse. Yes. So matrix A can be written as P D P inverse, because you see this is D and this is A. So you want A. So what will you do? You will multiply P inverse from this side. So P inverse will come here, and then multiply P from this side. So P will be multiplied this side, correct? So you will get A is equal to P D P inverse. So this will be very, very important, because any function you apply here will be only translated to this capital D. For example, if I write A to the power N, it will become P D to the power N and P inverse. And it is very easy to write D to the power N, and it is difficult to write A to the power N. So in this form it can be written very easily. For example, if suppose I have a diagonal matrix like this, 2 cross 2, suppose lambda 1 lambda 2 is here, 0 0. This is the diagonal matrix. So if I write D to the power 100, it will be lambda 1 to the power 100, 0 0, lambda 2 to the power 100. So the functional value of D is very easy to write. Or if I write with same e to the power D, if I want to write, so it will be just translated to here, e to the power lambda 1, e to the power lambda 2 and 0 0. Okay. And if I want to write suppose sine of D, it will be translated to sine of lambda 1 0 0, sine of lambda 2. Okay. Is it okay?
Yes, sir.
Yes, sir.
So if you write any matrix P and make this transformation, this is similarity transformation. But if this P are linearly independent eigenvectors, then it becomes diagonalization. So that is how the special, that is how, what I mean by special similarity transformation, in which this matrix becomes a diagonal matrix. So it will be better to take an example and understand whatever I have told you. So if a matrix is given as, suppose, so this will be very good example to understand the complete thing, whatever I have told you. So suppose A is a matrix given by 6 minus 3 and 4 minus 1. Let us understand by using a 2 cross 2 matrix. Okay, and I want a transformation A cap. Okay, this I want. So please help me in writing the eigenvalues and then eigenvectors quickly. So the complete cycle you should know. That's why the question will be asked from here, because it consists of everything, na? It consists of your eigenvalues, consists of eigenvectors. So complete thing is used here. So just write A minus lambda I is equal to 0. So what you will get from here? 6 minus lambda minus 1 minus lambda, correct? And plus 12 is equal to 0. Yes? And
Yeah.
this will give actually lambda plus 1 and lambda minus 6 plus 12 is equal to 0. And tell me what you will get. Lambda square minus 6 lambda plus lambda plus 12 is equal to 0. So it will become lambda square minus 5 lambda plus 12 is equal to 0. So what are the roots?
2 and 3.
Hmm?
2 and 3.
So lambda is equal to 2 and 3.
सर -6 भी तो आएगा ना?
Uh,
6 should be
एक
plus
मिनट
6 last
मैंने
time.
यहाँ पे ये नहीं मल्टीप्लाई किया. -6 -6 तो ये क्या हो जाएगा? It will become +6 ना? It will become +6. This last term -6 and +12 will become +6. Okay?
So lambda will be -2 and -3.
So you have told me, I have not calculated. Na? I'm just
Lambda is
so lambda square minus 2 lambda minus 3 lambda plus 6 is equal to 0. So it will become lambda lambda minus 2 and minus 3 lambda minus 2 is equal to 0. So lambda will become 2 and 3. Okay, and from here also you can see the trace is 5 and the summation is 5. So you can check also. Correct? So let us get the eigenvectors quickly. What are the eigenvectors corresponding to this? So corresponding to lambda is equal to 2. Quickly calculate. So you will get 4 and here -3, -3 and 4, and let the eigenvector is some x1 x2 is equal to 0. Correct? Keep on checking. So it will become 4
4x1 minus 3x2 is equal to 0.
minus 3x2 is 0, and this one is also same, huh?
Yes, sir.
So you will get 4 of x1 is equal to 3 of x2. Okay, so if I take the value of x2, suppose I take the value of x2 as 4, so what will be the value of x1? It will be 3. Correct? So it will become 3 and 4. And so this is the vector. And the second one, this is the first eigenvector. Let's call it x1. The second one, x2, corresponding to lambda is equal to 3. So what you will get? 3. 3 minus 4 and minus 3 and 4. Correct? X1, x2 is equal to 0. Okay? So these are also same equations. So x1 minus x2 is equal to 0. Please see this. So x1 becomes equal to x2. So this second vector is like this, 1, 1. Correct?
Yes, sir.
So I can take a P matrix like this, 1, 1, 3, 4.
Sir, we do not require to normalize the vectors.
Because it is P inverse, then come P and P inverse, both are there, na?
Okay.
So whatever P you take P inverse of that. Okay. So up to this, it is clear. This is the same thing what we
Yes,
have
sir.
been doing. So now let us quickly write P inverse of this. P inverse. What will be that? You can write directly, na? You know or not? इसको exchange कर देते हैं. 4, 1. And these things are written with minus sign. Minus 3 and minus 1. You know this or not?
Yes, sir.
This is the P inverse.
Yes, sir.
And formula is same, adjoint A upon determinant A. And what is the determinant value?
1, sir.
So this is the P inverse. And now let us write the similarity transformation. A cap is equal to, what I will write? P so what is the value of A cap? P inverse A and P. This is the definition, na?
Yes, sir.
Quickly write it and let us multiply it. So A cap will be equal to P inverse, which is 4 minus 3 minus 1, 1 into A. What is A? What is it?
6
minus 3, 4 minus 4.
6 minus 3, 4
minus 1.
minus 1. And then the value of P, that is 1, 3, 1, 4. So A cap will be equal to, write it quickly, multiply it. 2 cross 2 you can multiply, na? Or not?
So it's 3002.
Multiply the matrices. You know how to multiply?
Yes. Done, sir.
I'm talking about others. Everybody knows how to multiply 2 cross 2 matrix?
Yes, sir.
Yes, sir. Yes.
So,
Yes.
so what was this value corresponding to which eigenvalue? 1, 1?
Corresponding to x lambda is equal to 3.
And this?
Lambda is equal to 2.
So after diagonalization, you will get 3 here, 2 here, and 0, 0. So this is a diagonal matrix. which is a diagonal matrix. So suppose they ask a to the power 4, then how you will write? P d to the power 4 P inverse, correct?
Sir.
And this is d in this case. So what is the value of d to the power 4? It is 3 to the power 4, 0, 0, 2 to the power 4. So you will multiply these values. You will write p here, which is 1, 3, 1, 4. Then you will write d to the power 4, which is 81, 0, 0, 16. And then P inverse, which is 4 minus 3 minus 1, 1. And tell me the multiplication of this quickly. That will be the value of a to the power 4. Multiply this and tell me the value. This will be a 2 cross 2 matrix like this. What is the value here? You can write now. Now next thing is that I also told you that if I want to calculate the eigenvectors of a cap, so corresponding eigenvectors can be written as, suppose y1 I want to write, so that will be just P inverse x1, correct? That I also told now.
Yes, yes, sir.
So this will be equal to P inverse is 4 minus 3 minus 1 and 1. And what is the eigenvector?
3, 4.
So what is the eigenvector x1?
3, 4.
So suppose that is 3, 4. So corresponding to this vector will give you the value of eigenvector of, so this will come out to be 0, 1. This will be the eigenvector of your A cap matrix. And similarly y2 can be calculated. Similarly y2 can be calculated as P inverse x2, P inverse x2. And what is the value of x2? 1, 1. Yes. So suppose this is suppose x1 and this is suppose x2. I am doing it like this. So this value will amount to 1, 0. So you will get two linearly independent vectors of A cap also. So this is the complete story. ये किसी का आया क्या? Anybody has calculated this?
Sir, 276.
2
76
hmm.
minus 195.
minus 195
260
260
minus 179.
minus
79.
Very good. So this is a to, now you can see, even if it is a to the power 100, na? Even if it is a to the power 100, your you need not to multiply the matrix A by 100 times. Just you have to multiply it 3 times, 2 times, correct? इसको इससे फिर जो आएगा इससे, only 2 step. So that's why it is so important in operations. Are you getting my point or not? Suppose it is a to the power 100, so otherwise you have to multiply it 100 times. But here you have to multiply only 2 times. Okay?
Yes, sir. Sir, why we have taken y1, sir? Y1.
Why? Why we have taken?
Yes, sir. P inverse x1. X1 is the eigenvalue, sir.
Yes.
Okay.
Just wait.
Sir, can you once tell the shortcut method for the 3 by 3 matrix how to find the inverse?
No shortcut method for 3 by 3. It happens for 2 cross 2 because like you have a matrix like this. Suppose A is equal to A, B, C, D. Okay. Suppose this is the matrix. So what you do, you write adjoint of A. Huh? So what is adjoint of A? Adjoint A. So it becomes you know how to write. First you make a cofactor matrix and then you take the transpose. So first of all, the cofactor matrix. So the cofactor matrix is, with this it becomes D, and with this it becomes minus C. Correct? With this it becomes B, and with this it becomes minus A. Then you take the transpose, so that becomes adjoint A. So it becomes D minus C, B minus A. This is the transpose.
The minus B.
D minus C. Sorry.
Minus भी नहीं होगा.
Wait. This is D, then minus C, and then minus B, and then A. Because it is 1 1, 1 2, 2 1, 2 2. Okay. So then what will happen? It will become D minus C and minus B A. Okay. This is adjoint, and then A inverse. A inverse is 1 upon the determinant value of this. So what it will become?
Adjoint A divided by
AD minus BC into DA minus B minus C. So this becomes the formula. So you see, AD is just reversed, and this got negative sign, and determinant value in our case was 1. Otherwise you have to put the determinant value. Correct? समझ आया? Why there is a shortcut for 2 cross, but if you start doing it for 3 cross 3, there is no purpose will be solved. Huh? That means you have to solve it. चलो ये भी note कर लो जरा. So this is inverse of a matrix. I just gave you. Those who don't know can write this. Cofactor matrix में जो sign होता है, that is minus 1 to the power I plus j. So that's why it is 1 plus 1. So positive here, but 1 plus 2 negative here. Again negative here, again positive here. Because the sign goes like this. Okay? Inverse is clear?
Yes, sir.
So revise this inverse, everybody. You should know how to calculate inverse. Now I just I will give you a homework just to solve it. Try solving it. The matrix A is given by 7.3, 0.2, minus 3.7, minus 11.5, 1 and 5.5, 17.7, 1.8, minus 9.3. Okay, suppose this is a matrix, and I will give you everything. Don't worry, just you check everything. So A, I am giving you the values of lambda 1, lambda 2 and lambda 3. These are the values, eigenvalues. So you will check each and every part, okay? And then B, the
तो
eigenvectors.
सेकेंड रो में 10 और 18 लिखा है ना कि 1.0 लिखा है 10 एंड अच्छा सॉरी
Okay. And the eigenvectors are -1, 3, -1 and 1, -1, 3 and 2, 1, 4. 2, 1 and 4. These are the eigenvectors. And then C, the diagonal matrix will be, you know what will be the diagonal matrix. So 3, -4 and 0 will come here and it will become 0, 0, 0, 0 and 0. So this will be the diagonal matrix, okay? So do this. This will give you the complete understanding of everything. Okay?
सर 1/10 कॉमन लेके करना पड़ेगा ना
किस चीज को?
ये जो 7.3 इसमें फ्रैक्शन में चलने दें इसको
फ्रैक्शन में ही चल, वो ऐसा नंबर लिखा हुआ है ना कि बहुत फटाफट हो जाएगा
ओके
अगर आप थोड़ा दिमाग लगाओगे, थोड़ा सा एलिमेंट्री और ट्रांसफॉर्मेशन करोगे, एवरीथिंग विल बिकम ओके. So this is just for your, practice. Try to do it, confirm that. Is ये number दिया है so that to just increase your concentration with decimals, okay? Otherwise in exam they don't give the decimal things usually. So ये सारा decimals clear है ना? नहीं तो आप पता चला पूरा number लिख लो फिर कुछ और ही आएगा. It is clear?
यस सर
So now I want to solve few problems, and before that I want to discuss one topic and then we will solve problems from previous. Can I erase this?
सर पी लिखते टाइम ऑर्डर से कुछ इफेक्ट नहीं होता
ऑर्डर से कुछ इफेक्ट नहीं होगा.
ओके सर
क्योंकि P इनवर्स वही लेना सेम, ये नहीं कि P कुछ और लिखो फिर P इनवर्स किसी और का निकालो. Are you getting?
यस सर
So let me discuss little bit about, I told you little bit about functions, but let me discuss again functions of matrices. And I told you that A can be written as P D P inverse, correct? So if I make this function of A, suppose function of A is A to the power n. This is a function, suppose. So A to the power n will become P D to the power n P inverse. This I told you, correct? But apart from this, there are other functions also, and especially this part I am following Erskine, so you can see if you want the functions of matrices, but otherwise what I am teaching will be sufficient for your exam purpose, huh? This I already told you. Now I want to go little ahead of this. So suppose I take a matrix A, which is n cross n matrix. So I can write these matrices as a power series also. For example, e to the power A can be written as, I plus a to the power 1 by 1 factorial plus a square over 2 factorial plus dash dash dash. Yes, this you know already. And please remember, A can only be square matrix. Otherwise, these things will not work because, you know, dimensionally they will become incorrect. So this can be written as summation. If I write j is equal to 0 to infinity and a to the power j over j factorial. You agree with this? So this becomes the exponential series for a matrix. So similarly, we can write sine A also, and we can write cos A also. So sine A can be written as, you know, the series j is equal to 0 to infinity. You can open the series and you will find out that it is the same, e to the power j minus 1 to the power j a to the power 2j plus 1 over 2j plus 1 factorial. You open this, so you should find a minus a cube by 3 factorial plus dash dash dash, because this is a sine series. And similarly, cosine series we will find out. So this becomes even here. Summation j is equal to 0 to infinity, and this becomes minus 1 to the power j a to the power 2j over 2j factorial. So how this will look like? This will look like I minus a square by 2 factorial plus a to the power 4 by 4 factorial minus dash dash dash, the cosine series. Okay. Any doubt in this?
No doubt, sir.
Very good. So all this is clear. I can erase this.
Yes, sir.
Yes, sir.
So this all you already know, but you know, everything has to be understood in context of a particular thing. So like यहाँ पे everything we are understanding in context of matrices, because you already know this in context of algebraic series or algebraic numbers, that you already know. But in context of matrices, we are seeing this. Okay. Now a very special matrix in quantum mechanics is Pauli matrices. You have heard about it
In quantum mechanics.
in quantum mechanics?
Yes, sir.
Pauli matrices. So Pauli matrices uh, have very unique properties. So suppose I write sigma k as a Pauli matrix, where k is equal to 1, 2, 3, 1, 2, 3. So that means this is like some people write it like sigma x, sigma y, sigma z. I am writing it as sigma 1, sigma 2, sigma 3, all three polyspin matrices. Okay. And let theta is a real number. Okay. And then e to the power I sigma k theta, this will be I2 cos theta plus I sigma k sin theta. So this is how the Euler's formula will go. And what is this I2? Anybody can tell?
Identity.
2 cross 2 identity matrix. When it is written 2 here means 2 means that n cross n which was given here is 2. You can write here. This is a 2 cross 2 identity matrix. Identity matrix. Please off your mic. Okay. So this is regarding Pauli's matrices and how. So you can take one, like you can take as an example, you should take some matrix, Pauli matrix, e to the power I. Suppose I take the first one, sigma 1 I theta, and then it will become the identity matrix 2 cos of theta plus I sigma 1 sine of theta. So this you can check for yourself. Otherwise, see, agar exam mein 4 option ho and you have not seen things like this, it will become so difficult to write. So this was the first thing. There is a trace formula also. Trace, you know, everybody? So the determinant of e to the power a matrix will be equal to exponential trace of a. See, the determinant of e to the power a is equal to exponential trace of a. So can you give me a matrix 2 cross 2 which we have already dealt with? We already know everything about that. Just पीछे से देख के जल्दी से कोई. The first one which I started, 2 cross 2.
Sir, 6
6
minus 3
minus 3
4
4
minus 1.
minus 1. Very good. This is a 2 cross 2 matrix. So suppose this is the matrix and we want to write the determinant value of e to the power a. So how you will calculate this? First of all, you will calculate eigenvalues, eigenvectors, p inverse, na? All that, and then e to the power a. तभी तो calculate कर पाओगे. Yes? The functional matrix, then only you can calculate, na? A to the power n की जगह e to the power a लिख दोगे. And please see this, but how simple it is. We have to just write e to the power, the determinant value of this will be just e to the power trace of a, which is 5. Got it or not?
Yes, sir, got it.
Otherwise, this value will be difficult to write because you know a is equal to p d p inverse, and if you will write e to the power a, that will become p e to the power d p inverse. All that you have to solve and then calculate the determinant value. Correct? So this is very nice formula for determinant of that. Now this concept is also used in quantum mechanics, which I am going to tell you. So can I erase this? Homework is try this at least for one Pauli spin matrix. You take sigma 1, the first matrix, and then try to do this, okay?
Excuse me, sir.
Hmm.
So, is this general formula or it is only applicable for exponential?
Which formula?
The trace formula.
So what is trace formula?
Determinant of e raised to a is equal to e raised to trace of a. It is applicable for f of a, I am asking.
Determinant of e to the power a is equal to what?
E to the power trace of a.
Trace of a. So you tell me, what is written here?
Okay, sir.
So matrix is like something, मैं कितना भी शुरू करूं कि ये एक अरेंजमेंट है, ऐसे रख देते हैं, all those things are not important. It is like when you read, when you apply, when you use, for example in programming, or for example in when you do research, you find that matrix is what matrix is. So in a definition, वो definition है जो वो बेकार, the definition is of no use. but it is like something which you become familiar when you read so much or when you use it actually, then you get to know what matrix is. Like, you know, there is a famous dialogue in that Matrix film. वो उसका कॉन्टेक्स्ट तो दूसरा है ना, आपने वो हॉलीवुड वाली है ना, उसमें वो बोलता है कि यू हैव टू इन्वेंट इट फॉर योरसेल्फ what matrix is. So same thing is with our matrix also. So we have to use it and we have to just invent it for ourselves, that what it is. And in quantum mechanics, see how it plays a very, very important role. And I will tell you uh, a law which is known as spectral decomposition. नाम से मत घबराना, spectral decomposition law. So spectral decomposition law is for a matrix A, which is Hermitian. Like in quantum mechanics, we also use all matrices which are Hermitian because the eigenvalues are real. So it is something so beautiful. Please see, any function you want to write for A, any function you want to write for A can be written as summation I f lambda I into Ri. The symbols you understand now?
Yes, sir.
The inner product symbols.
Branch,
Now,
branch.
the inner product symbols of quantum mechanics. You understand this now? How this is just
Yes, sir.
this is just multiplication. Here row and column will be changed. Na? Okay. Now please see this. अब ये ऐसे नहीं समझ आएगा, but let us take an example. Example में जो n cross n matrix है, suppose that is a 3 cross 3 matrix, A matrix, and you want to write some function e to the power a. This is a functional matrix, or you want to suggest any other function. Let me take this time different. आप कहोगे बार बार e ले रहा है. Tan of a. This is okay? बोलो भाई.
Yes, sir.
So 3 cross 3 matrix will have 3 eigenvalues, lambda 1, lambda 2 and lambda 3. You agree with this?
Yes, sir.
So this will become f of those who understand this summation and all. Corresponding to lambda 1, let eigenvector is x1, x2 and x3. Okay? The eigenvectors. So it will become x1 plus, कोई बोलेगा जल्दी से? And here let me write tan of lambda 1, then tan of lambda 2 x2 plus tan of lambda 3 x3. So this is how it is, you know, decomposed into all these 3 eigenvectors in the form of eigenvectors. So this is known as spectral decomposition. So in quantum mechanics, these eigenvectors become wave vectors there. Then eigenvalues become energy eigenvalues. So then you write a function, it comes in 3 parts or more parts, whatever is the order of this matrix. And in that case, that will be a Hamiltonian matrix, capital A. Okay. So इस तरीके से ये same चीज वहां भी चलती है. इसमें कोई problem हो तो बताओ. This is end of today's class.